Arithmetic sequence word problems. Our next problem, give the number of terms for a sequence with a sub 1 equals to negative 7. The last term is positive 25 and the common difference is positive 8. Okay, so again, our given, we have a sub 1. This is equal to negative 7. Okay, the common difference is 8. So this is d equals to 8. And our last term, okay, we do not know if what is the specific term, but we know that this will be the last term. So we will start finding the values of the terms when it is equal to 25. So our last term will be positive 25. So the formula for finding the value of the terms in an arithmetic sequence is a sub n equals to a sub 1 plus n minus 1 multiplied by d. Okay, so let us find the second term. Let us start with the second term. So our a sub 2. A sub 2, this will be equal to the value of a sub 1, negative 7, plus our n here. Our n, since this is the second term, our n will be 2 minus 1 multiplied by d. Our d is positive 8. So a sub 2 here, this will be equal to negative 7 plus 2 minus 1 is 1. 1 multiplied by 8, that is positive 8. Our a sub 2 would be equal to positive 1. Okay, so since we have here a sub 2, we can now just find easily a sub 3. So a sub 3 here would be equal to, our a sub 1 is negative 7, or rather it will be easier. So since we have a sub 2 here which is 1, so we will just add the common difference. So our a sub 2 is 1, so we will just add here the common difference, which is 8. So 1 plus 8 would be equal to 9. Okay, so for our a sub 4, this will now be equal to our a sub 3, that is positive 9, plus the common difference, which is 8. Okay, so we will just add 8 here. So 9 plus 8 would be equal to 17. So this is not the last term yet, since this is just 17. So let's proceed to a sub 5. A sub 5 would be equal to the value of a sub 4, that is 17, plus the common difference, which is positive 8. So 17 plus 8 is 25. So these are now our terms for the arithmetic sequence. Our first term, our first term is negative 7, followed by our a sub 2, which is positive 8. Okay, and our a sub, or rather a sub 2 is positive 1. So negative 7, positive 1. A sub 3 is positive 9. A sub 4 is positive 17. And a sub 5 is positive 25. So these are our final answers. Arithmetic sequence word problems. Our next problem, what is the second and fourth terms of the sequence when the third term is positive 76 and the fifth term is positive 54? Okay, so our first term is an unknown. We do not know that. Also, we have to find the second term. Our third term is positive 76. Our fourth term is an unknown, and our fifth term is positive 54. Okay, so we need to find for the first term, the second, and the fourth term. The formula for finding the missing terms or the formula for finding the value of terms in an arithmetic sequence is a sub n equals to a sub 1 plus n minus 1 multiplied by d. Okay, so since we do not have the value for a sub 1 here and we do not have the value for d, we will first find d using the formula for the third and the fifth terms. Okay, so the formula for the third term, this is a sub 3 equals to a sub 1 plus n minus 1 multiplied by d. The value for our a sub 3 is positive 76. This is equal to a sub 1 plus our n here. Since this is the third term, our n here will be 3 minus 1 multiplied by d. So 76 is equal to a sub 1. 3 minus 1 is 2. So 2 multiplied by d, this will be plus 2d. This will be our equation 1. Now for the fifth term, we have here a sub 5 equals to a sub 1 plus n minus 1 multiplied by d. The value for a sub 5, we have positive 54. This is equal to a sub 1 plus our n here is 5 minus 1 multiplied by d. So 54, this is equal to a sub 1, 5 minus 1 is 4. 4 times d, that is positive 4d. Let's call this as our equation 2. Now looking at the two equations, we can see that if we subtract the two equations, we can cancel out the a sub 1, so that what will be left will be the d. Okay, so let us subtract equation 2 from 1. So subtract equation 2 from equation 1. Now we need to subtract this because 76 is bigger than 54. Okay, so our equation 1 is positive 76 equals to a sub 1 plus 2d, and subtract this by equation 2, which is 54 equals to a sub 1 plus 4d. 76 minus 54, this is equal to positive 22. A sub 1 minus a sub 1 is 0, and positive 2d minus positive 4d, this will be negative 2d. So we can interchange negative 2d equals to positive 22. So to find 4d, we need to divide both sides of the equation by negative 2. So we can cancel out here negative 2. Negative 2 divided by negative 2 is positive 1. So our value now for d, okay, our d here will be 22 divided by, this is, 22 divided by negative 2. Okay, so 22 divided by negative 2 is negative 11. So our d, or the common difference, is negative 11. Let us now try to solve a sub 1. Okay, so for a sub 1, we are still going to use a sub 3. So we have here a sub 3 equals to a sub 1 plus n minus 1 multiplied by d. So for our a sub 3, we have positive 76. We will have here positive 76 is equal to our a sub 1 is a known plus our n, this is the third term, so this will be 3 minus 1, that is 2, multiplied by d, which is negative 11. So positive 76 equals to a sub 1 positive 2 times negative 11, this will be negative 22. So a sub 1 here, to find for a sub 1, we need to transpose negative 22 to the other side. So negative 22, we are going to transpose this to the other side. So a sub 1 here would be equal to 76. If we transpose negative, this will change sign. This will become plus 22. So our a sub 1 our a sub 1 would be equal to 76 plus 22, and this will be equal to positive 98. Okay, so we need to find now for a sub 2, a sub 2, a sub 4, okay, a sub 2 and a sub 4. So for a sub 2, this will be a lot easier. So our a sub 2 here, we are just going to add the value of d, which is negative 11, to our a sub 1. So this will just be a sub 1 plus d. Okay, so a sub 2 here will be a sub 1, which is positive 98, plus our d, which is negative 11. So our a sub 2 here will be equal to positive 87. Okay, so positive 87. Okay, and then for our, let's check, for our a sub 4. Our a sub 4, this will be equal to, we will just add the value for the common difference to our a sub 3. This will be a sub 3 plus d. A sub 4, our value for a sub 3 is positive 76. So this will be a sub 4 equals to positive 76 plus our d, which is negative 11. So our a sub 4 here, this will be equal to 76 plus negative 11. This will give us positive 65. So these are now our final answers. Arithmetic sequence word problems. Our next problem, what term is 60 or is positive 62 if a sub 1 is equal to positive 34 and a sub 3 is positive 48. Okay, so our given, we have a sub 1 equals to positive 34. Okay, for a sub 2, we do not have an a sub 2. Okay, let's try to rewrite this so that it will be easier. So again, our a sub 1 is positive 34. We do not have a sub 2. Our a sub 3 is positive 48. And we do not know what will be the terms here, but we know that our last term is positive 62, or rather, positive 62 is one of our terms, so we need to find if this is what term. Okay, so our d here, or our common difference, is also unknown, so we need first to find our d. So to find for d, we are going to use the formula for the third term. So the formula here is a sub n equals to a sub 1 plus n minus 1 multiplied by d. So our a sub n here will be a sub 3 equals to the value of a sub 1, that is positive 34, plus our n here, this is the third term, so our n will be 3 minus 1 multiplied by d. Our a sub 3 is positive 48. This will be equal to 34 plus 3 minus 1 is positive 2 multiplied by d. Okay, so 48 equals to 34 plus 2d. So to find for d, we need to transpose positive 34 to the other side. So 34, transpose this to the other side. So we can rearrange this. Okay, so 2d, we will put here positive 2d, and we have here positive 48. If we transpose positive, it will change sign. This will become minus 34. So 2d will be equal to 48 minus 34. This is positive 14. So to find for D, we need to divide both sides of the equation by 2. So 2 divided by 2, this will be equal to 1. So this is positive 1. So 1 multiplied by D, that is equal to positive D. And 14 divided by 2 is positive 7. We now have our value for D. So D here is equal to positive 7. Okay. Let us now find, okay, for A sub 2, let's just complete this. So what will be our D sub 2 here? Now, since we know that D, or the common difference, is 7, our A sub 2 now, this will be easier. We will just add A sub 1. We'll just add A sub 1 by 7. So this will be equal to 34 plus 7. So we will have here positive 41. So our second term here is positive 41. Now for our A sub 4, we will just add A sub 3 and 7. So this will be A sub 3 plus our common difference, which is 7. So this will be 48 plus 7. This is equal to positive 55. Okay. So for our A sub 5, let's try if this is positive 62. So our A sub 4 here, first let's write here our A sub 4, which is positive 55. So our A sub 5 will be equal to A sub 4 plus 7. Our A sub 4 is positive 55, okay, plus 7. This will be equal to positive 62. Okay, so our positive 62 is already here. So we can now say that positive 52 is the fifth term of our given problem. So this is positive 62, and positive 62 is the fifth term. Okay. So this is now positive 62 and the fifth term. They are now our final answers. Arithmetic sequence word problems. Our next problem: solve for the value of the variable A, 4a plus 6, 18 plus a, and 9a minus 3 to be an arithmetic sequence. So our given here, they are an arithmetic sequence, and the given we have 4a plus 6. This is the first term, followed by the next term, which is 18 plus a, and the third term will be 9a minus 3. So we need to find the value for a so that this 3 will be an arithmetic sequence. But we know that if we subtract the two consecutive terms, we will get the common difference, or D. So if we subtract 9a minus 3 and 18 plus a, we will get D here. And if we also subtract 18 plus 8 and 40a plus 6, we will also get D there. Okay. So let's make this clear. So if we subtract 9a minus 3, so subtract this by 18 plus a, this will be equal to D. And if we also subtract 18 plus a, subtract this by 4a plus 6, this is also equal to D. So here D would be equal to D. Okay, so let's substitute here the values of D. So we have 9a minus 3 minus 18 plus a. This is also equal to 18 plus a minus 4a plus 6. Okay, so let's continue. 9a minus 3. Okay, So negative times positive 18, that will be negative 18. Negative times positive a, that will be negative a. This will be equal to 18 plus a. Negative times positive 4a, this will be negative 4a. Negative times positive 6, that's negative 6. Combining like terms, we have 9a minus a. This will be equal to 8a. Negative 3 minus 18, this will be negative 21. And we will have here 18 minus 6. This will be equal to positive 12. And we have positive a minus 4a. This is negative 3a. Okay. So let us now combine like terms. So we are going to transpose minus 3a to the other side. And we are going to transpose here negative 21 to the side of positive 12. Okay. So on the side of positive 8a, we will have 8a. If we transpose negative, this will change sign. This will become positive 3a. And we will have here 12. If we transpose negative 21, it will change sign. It will become positive 21. So 8a plus 3a, that is equal to 11a. 12 plus 21, that is equal to positive 33. And to find 4a, we need to cancel out 11. So divide both sides of the equation by 11. Okay, so 11 divided by 11, that is equal to 1. So 1 multiplied by a, this is positive a. And 33 divided by 11 is positive 3. So our a here is equal to positive 3. Okay, so let's check. First term is 4a plus 6. We have here 4a plus 6. Our second term is 18 plus a. We have 18 plus a. Our next term is 9a minus 3. Okay, so we have here 9a minus 3. The value for a is positive 3. So let's substitute. 4 multiplied by 3 plus 6, 18 plus 3, and 9 multiplied by 3 minus 3. So this will be 12 plus 6. 18 plus 3 is 21. This will be 27 minus 3. So our final here will be 12 plus 6 is 18. 21. 27 minus 3 is 24. Okay, so we have a correct arithmetic sequence wherein the D is positive 3. And these are our final answers. Arithmetic sequence word problems. Our next problem, what is the first, second, fourth, and the fifth term if the third is 50 and the sixth is 14. Okay, so our given, we do not have the first, the second, the third term is positive 50, so we do not have the fourth and the fifth, and the sixth term is 14. So we need to find for the first, the second, the fourth, and the fifth term. Okay, so the formula for finding the terms of an arithmetic sequence is a sub n equals to a sub 1 plus n minus 1 multiplied by d. So since we do not have an a sub 1 and we do not have a d, we are going to use the equation for the third and the sixth term. The equation for the third term will be a sub 3 equals to a sub 1 plus our n here, This is the third term, so our n will be 3 minus 1 multiplied by d. The value for a sub 3 is positive 50. This will be equal to a sub 1. Positive 3 minus 1 is 2. 2 times d, that is positive 2d. Let us call this as our equation 1. And for our sixth term, we have a sub 6. This is equal to a sub 1 plus, okay, our n here is 6. So this will be 6 minus 1 multiplied by d. The value for a sub 6 here is positive 14. This will be equal to a sub 1 plus 6 minus 1, that is 5. 5 multiplied by d is 5d. We will have here equation 2. So looking at the two equations, we can subtract 2 from 1 so that we can cancel out a sub 1. Okay, so subtract equation 2 from equation 1. Our equation 1 is 50 equals to a sub 1 plus 2d. So subtract this by 14 equals to a sub 1 plus 5d. So subtracting, we have 50 minus 14. We will have here 36. And a sub 1 minus a sub 1 is 0. Positive 2d minus positive 5d, this will be negative 3d. So 36 equals to negative 3d. We can rearrange this. We can write it this way. Negative 3d equals to positive 36. To find for d, we need to divide both sides of the equation by negative 3. Now, negative 3 divided by negative 3, we can cancel this out. This will be equal to 1. And 1 multiplied by d, this will be d equals to 36 divided by negative 3. Okay, this will be equal to negative 12. Okay, so we have our d here, which is equal to negative 12. Okay, we can now find for the missing terms. So first, let us find for a sub 1. So to find for a sub 1, we are going to use again this equation. Okay, so using a sub 3. The equation for a sub 3 is equal to a sub 1 plus, and our n here is 3 minus 1 multiplied by d, which is, our d is negative 12. Okay, so our d is negative 12. And our a sub 3. Our a sub 3 is positive 50. So we will have here positive 50 equals to a sub 1 plus 3 minus 1 is 2. And 2 multiplied by negative 12, that is negative 24. Okay, so let's erase this. And this is negative 24. So to find for a sub 1, we need to transpose negative 24 to the other side. So transpose this to the other side. So what will be left now will be 50. If we transpose negative, this will change sign. This will become positive 24 equals to a sub 1. So we can rearrange. Okay, let's put a sub 1 here. 50 plus 24, that is positive 74. Okay, so let's put here our first term is, okay, our first term is positive 74. So positive 74. So to find for the second term, this will be easier. Our a sub 2, we are just going to add 74 by our d. Our d is negative 12. Okay, so a sub 2 now would be equal to 74 74 plus negative 12, that would give us positive 62. So let's go back here. Our second term will be positive 62. And for our fourth term, okay, this is easy. We will just a sub 4. This will be our third term, which is 50. Our third term, which is 50, let's just add negative 12 again. So this will be equal to positive 38. Okay, so let's put here positive 38. And for the last missing term, that is the fifth term. So a sub 5 would be equal to our a sub 4, 38 plus negative 12. So this will be equal to 38 plus negative 12. This will give us positive 26. Okay, so our fifth term here is positive 26. So positive 74, positive 62, 50, 38, 26, and 14. They are our final answers.